Okay, we'll go ahead and get started. I wanted to go over the study guide with you guys to help you prepare for the midterm exam coming up this week. So let me get everything set up and we will start working on the study guide for the midterm exam in just a second. Can everybody hear me okay? Okay, thank you. Let me go ahead and share my screen with everyone. Let's see. Hold on just a second. Okay, you should see two screens, a split screen, my whiteboard, and also a version of the midterm study guide. Can everybody see that okay? Okay, cool. Uh, let's get started. Question one, find the domain of the square root function, then use the domain to choose the correct graph. We have a square root, so we know that a square root has to be 0 or greater than 0. So that's what we set the inside part of our radical equal to find the domain. So 5x minus 30 is greater than or equal to 0. And then we will just solve for x. So we'll add 30 to both sides. And we have now 5x is greater than or equal to 30. And the last step, just divide both sides by 5. Remember though, if you're dividing both sides by a negative number, then you have to change your inequality symbol to its reciprocal. But here we don't have to do that. So we get x is greater than or equal to positive 6. Now, on the number line, that means everything greater than 6 or equal to 6. So that's everything shaded in this direction. And you guys know anytime you have less than or equal to or greater than or equal to, you use brackets in your interval notation. If you just had less than or greater than, then you would use parentheses. So in interval notation, this is everything greater than or equal to 6, or starting at 6 and going forever toward positive infinity. So choice C is the right answer. I believe your entire or most of your midterm exam is multiple choice. And I think there are also the same amount of questions on the midterm as there are on the study guide. Question 2, simplify the expression. We have the square root of 36 to the 8th power. It's not shown, but we know that our radical is understood to be root 2. Well, the square root of 36 is 6. And to break down the letter, just take a root and divide it into your exponent. So 2 can go on to 8 4 times with nothing left over. That 4 indicates an exponent of 4. So choice C is the right answer. Question C, I mean, question C. Question 3 is very easy. You can either use your calculator or figure it out mentally. Find the indicated root. The cube root of 1000, well, if you think about it, the only number you can multiply times itself 3 times is 10. 10 times 10 times 10 is 1000. So the correct answer to number 3 is D, 10. Are there any questions about the first 3 problems? Okay. Question 4 is pretty easy also. And this leads me to a good tip. If you get stuck on a question, skip it, come back to it. Do a question that you know how to do. That way, when you come back to the question that stumped you, you'll have probably already figured it out by then. Question 4, rewrite the expression with a rational exponent. That just means rewrite using a fractional exponent. So we have the square root of 51xy, and that's all raised to the 3rd power. Well, the given radical, even the given root, I'm sorry, is root 2. So to rewrite this using a rational exponent or a fractional exponent, we bring down the 51xy. And to create your fraction exponent, you just simply put your given exponent over your given root. So just like that, B is our final answer. Sorry about that. There was a siren. I think a police or something passing by our house. Question 5. Use properties of rational exponents to simplify the expression. And part of the directions are cut off, but they say assume that any variables represent positive numbers. So we have 16x to the 10th power, y to the 10th power, and that's all raised to the 1/2 power. So this means that each power, everything on the inside is being raised to the 1/2 power, including that 16. So let's get that out of the way. 16 to the 1/2 power. When you change this back to a radical, this is the same thing as square root of 16. So we know that part is 4. Now, anytime you are raising an inside exponent with an outside exponent, you use something called the power rule. And to utilize the power rule, you multiply the exponents. So for both x and y, you'll multiply 10 times 1/2. Well, 2 can go into 10 5 times. So each exponent now is 5. Final answer, correct answer is A. If you have any questions while I'm working a problem, please stop me. Feel free to use the chat box, type your question, and I'll be glad to answer it. Question 6, simplify by factoring. Assume that any variable in a radicand represents a positive real number. So we have a number that is not a perfect square root. We have the fourth root of 32, x to the 15th power. You have to break down 32 until you find a factor, desirably the highest factor, that's a perfect fourth root. So we can break down 32 as 16 times 2. Because we know the fourth root of 16, in other words, what number can you multiply times itself 4 times to make 16? That is 2. So a 2 comes outside the radical, and a 2 stays inside the radical. Now, to break down the letter, you just take the given root and divide it into the given exponent. Four can go into 15 3 times, with a remainder of 3. The division tells you what exponents go outside and what exponents stay inside the radical. The top number tells you the exponent that goes outside the radical. So that would be x cubed. And the remainders tells you the exponent that stays inside your radical. So that would be x cubed as well. So final answer is choice B. Question 7, multiply and simplify, and same extra additional directions as before. Square root of 10x, square root of 10x times the square root of 2y. Now, if your radicals have the same root, then you keep the common root and multiply the inside terms. So when we multiply the inside terms, we get 20xy. Now the 20 is not in simplest form. We can actually break that down. The factors of 20 that would work are 4 and 5. Because we know the square root of 4 is 2, so that goes on the outside. And the 5 stays on the inside along with the x and y. So choice A is the correct answer. Are there any questions before we look at the next problem? All good so far. Okay. Question 8, also involving radicals, but we're adding, or well, this time around, we're subtracting them. And by the way, later on today, I will, once the video is done processing, I will share it in Canvas with everyone. Question 8, subtract and simplify terms if needed. So we have the cube root of 8y minus the cube root of 128y. Now the cube root in the first radical, the cube root of 8 is a perfect cube root. 2 times 2 times 2 is the common base. So we can pull a 2 on the outside of our radical, and y stays inside the radical. 128 is not a perfect cube root, so we need to see if one of its factors is. 128 we can break down as 64 times 2. Well, we know the cube root is 64. Again, think of what number you can multiply times itself 3 times to make 64. And that would be just 4. So a 4 goes on the outside. And 2y stays on the inside. Well, the cube root of y and cube root of 2y are not like terms, so we cannot combine them together. So this expression here is our final answer. Question 9, use the quotient rule to simplify, and same common directions as before. Now, since the entire fraction is under a radical, then that means each separate part is also under a radical. So we can split this fraction as square root of 6 over the square root of 4. Now the square root of 6 is already in simplest form, so we leave it alone. However, we can simplify the denominator by dividing 2 or the root into the exponent. So 2 can go into its to 4 2 times. So that would be x squared left in the denominator. And that is what answer? That is B for our final answer. The next question also involves radicals, but we're multiplying them now. Multiply and simplify. Since we're multiplying two binomials, we can use something y'all are familiar with, the FOIL method. So we have 3 plus square root of 5 times 4 plus 3 square root of 5. And let's go over the FOIL method. The F stands for your first terms. the first term in each parentheses. So that would be 3 and 4 here. And we're multiplying our terms together. The O stands for outer terms. And I equate my problem with, I think of my problem as a building. Most buildings have an entrance and an exit. So your outer term, your entrance is 3, and your exit is 3 square root of 5. So that would be 9 square root of 5. The I represents your inner terms, and those are the terms that are stuck in the middle of the problem. So that would be 4, or I'm sorry, square root of 5 and 4. And that's just 4 square root of 5. And then the last terms are just that, the last term in each pair of parentheses. So square root of 5 and 3 square root of 5. Now, square root of 5 times square root of 5 is square root of 25, which is 5. So our last term is actually 15. The last step, combine your like terms and also combine your first and last terms here. So 12 plus 15, sorry about the phone ringing in the background. 12 plus 15 is 27. And we can combine the square root of 5s together as well. So 9 plus 4, that would give us positive 13 on the square root of 5. And that is choice B. You'll have a variety of radicals where you're performing one of the 4 main operations, like addition, subtraction, multiplication, or division. Let's look at question 11, and then I'll stop if anybody has questions for me. Number 11 says rationalize the denominator. To us, that means you cannot have a radical in the denominator, so we have to get rid of it somehow. When you have a binomial and you're trying to rationalize the denominator, you multiply the top and the bottom of your fraction by something called the conjugate. And conjugate just means opposite middle sign, really. So we'll multiply the top and the bottom of our fraction by the square root of 17 minus 4. Now, we don't need to distribute or multiply the top part out. We'll just leave it in broken form. Now, let me show you a neat trick to multiply the binomials at the bottom. Because we have the same terms but opposite signs, gonna go pick him up. Okay, be careful. You just multiply the first 2 terms and multiply the last two terms. You don't have to do the entire FOIL method. Just multiply your first terms and your last terms. Now, y'all saw in the last problem, when we multiplied the square root of 5 times itself, well, it gave us 5. That's another neat rule to remember. The square root times itself is just itself without the radical sign. So here that would be 17, and then minus 16. And that gives us 1 in the denominator. So our final answer is A. 9 square root is 17. And it looks like my math lab went ahead and distributed that 9. So 9 times negative 4 is negative 36. Okay, let me stop for a second. Are there any questions at this point? All right. Just in case I do not finish this review, I'll make a separate video and finish up and share that in Canvas with y'all. Question 12. Solve the given radical equation. We have square root of 3x minus 6 equal to the square root of 2x plus 3. Now, the first step is to get rid of the radicals. You think opposite here. The opposite of taking the square root of something is actually squaring it. So we're going to square both sides of our equation. What's going to happen to the radicals and to the roots and the exponents? They will cancel each other out. So we're just left with now 3x minus 6 equal to 2x plus 3. And you're left with the linear equation to solve. With linear equations, it does not matter what side you pick for your letter. To move your letter, I'm going to move all my letters to the left side. So to do that, I need to subtract 2x from both sides. And that leaves us with x minus 6 equal to 3. We almost got our equation solved. In order to get x by itself, we need to move the negative 6 to the right-hand side. So to do that, we think opposite signs again, and we'll add 6 to both sides. So the solution set is A, just positive 9. Question 13, before we solve the radical equation, let's go over a basic definition of a square root. A square root will never ever equal to a negative number. That's not possible. It would actually not be a real number, or it would be an imaginary number. So if your square root is equal to a negative number, then there is no solution or it's an empty set. Let's change the 1/2 back to a radical. So in our fraction 1/2, the 2 is our given root, and the 1 is the given exponent inside the radical, but we don't need to, it's understood to be there. Now, to solve any radical equation, you need to get the part with the radical sign by itself. So that means for this problem, we need to subtract 5 from both sides. And that gives us the square root of x plus 3 equal to -2. Well, in order to get a real number, our square root cannot be equal to a negative number. In real number terms, that's not possible. So we stop here and declare that our solution is the empty set. Question 15, I'm sorry, I'm skipping. Question 14, find each product and write the result in the form a plus bi. That's standard form for complex numbers. So we have the square root of -16 times the square root of -64. Now, one property you know from imaginary numbers is that the square root of -1 is equal to I. And also what will help us with later problems is I squared is equal to -1. Now the square root of -16 we can break down as 16 times -1. The square root of 16 is 4. And the square root of -1 is I for imaginary. Break down the -64 in similar fashion as 64 times -1. The square root of 64 is 8. And the square root of square root of -1 is I. Now let's multiply our terms together. 4 times 8 is 32. And I times I is I squared. Now be careful. 32I squared is one of our choices. But anytime we have I squared, we must replace it with -1. So our final answer is A, -32. Again, make sure that you remember these two values. They are very important in complex numbers. I is equal to the square root of -1, and I squared is equal to -1. The next question also involves complex numbers with imaginary components. Divide and simplify to the form a plus bi. So we have 6 plus 7i over 9 minus 5i. Just like radicals, we cannot have imaginary parts in the denominator either. So we're going to get rid of it by using the conjugate again. So we'll multiply the top and the bottom by the conjugate of 9 minus 5i is just 9 plus 5i. Now we need to multiply everything out. Now I'm not going over the entire full method with this problem, but I'll go ahead and tell you when you use the full method up top, you should end up with 54 plus 93i plus 35i squared. Now, when you multiply the bottom, remember there you don't have to use the entire full method. You just multiply your first two terms. 9 times 9 is 81. And you also multiply your last two terms. So negative 5i times positive 5i is negative 25i squared. So let's bring that over. Our next step is to replace each I squared with negative 1. So that gives us now 54 plus 93i minus 35 all over 81 minus 25 times negative 1. Now up top, combine your integers. So 54 minus 35 is 19 plus 93i. In the denominator, a negative 25 times negative 1 is a positive 25. And that gives us 106 in the denominator. And we have to separate our fraction in order to get our answer in standard form. So we have 19 over 106 plus 93 over 106i. That is choice C. Any questions about complex numbers? Okay. Question 16, we must solve the equation by the square root property. Let me go over the square root property with y'all first. Square root property, if you have x squared equal to some positive or negative number a, in order to solve for x, you do opposites again. So the opposite of squaring something is actually taking the square root of it. So we'll take the square root of both sides. On the left-hand side, again, your root and radical cancel out. And remember, when you take the square root of a number, you're going to have two different answers. You're going to have a positive a, and you're going to have a negative a. So let's use the square root property to answer number 16. The first thing we need to do is get the x squared part by itself. So that means subtracting 361 from both sides. That leaves us now 289x squared equal to negative 361. Before we use the square root property, let's divide both sides by 289 to get the x squared by itself. Now, to solve for x, we just take the square root of both sides. On the left side again, the root and the exponent cancel out, leaving us with just x. And the exponent, the highest exponent 2, tells us how many answers we should get, whether they're rational answers or imaginary answers. So when you take the square root, you have to put a plus minus sign to guarantee two answers. The square root of 289 is 17. And the square root of negative 361, we can rewrite that as 361 times negative 1. The square root of 361 is 19. And the square root of negative 1 is our I. So D is our final answer. Question 17 is also a quadratic equation. Now, I don't mind if you solve these quadratic equations by whatever methods you understand better. You don't necessarily have to use completing the square. Me personally, I'm going to use quadratic formula. I would have used a quadratic formula. But I'll show completing the square in case that is another preference of yours. We have 7x squared minus 2x minus 2 equal to 0. Couple of things must happen in order to complete the square. Your constant must be on the other side. So let's get that out of the way by adding 2 to both sides. And another thing must happen. Your leading coefficient, in this case, in front of the x squared, has to be a positive 1. So that means in order to get a positive 1 in front of the x squared, we must divide everything by 7. So we now have x squared minus 2 over 7x equal to 2 over 7. I'm going to enlarge our whiteboard so we'll have more room to work. Now, with completing the square, here are the steps. The first step is take half of your middle term. So half of 2 over 7, or half of negative 2 over 7, I'm sorry. Well, you just multiply by 1/2. So the 2's cancel and we're left with negative 1 over 7. The last step, square. So we'll square negative 1/7. That's the same thing as negative 1 over 7 times itself. So that's equal to positive 1 over 49. You notice that I left some extra space there behind the negative 2x. That's so we can put in our 1 over 49. Now, of course, whatever you do to one side, we have to do the same thing to the other. So if I added 1 over 49 to the left side, then I got to add 1 over 49 to the right side. Now, although it doesn't appear to be this way, the left side of our problem is actually a perfect square trinomial. So it can be factored. Now, whenever you have fractions, it's kind of harder to factor. What I do is I just remember what I took half of. So when I took half of negative 2 over 7, that gave me negative 1 over 7. That is what you put in the last two spots. On the other side, we need to get a common denominator. So the common denominator is 49. Really, all we're doing is rewriting 2 over 7 as something over 49. 7 can go into 49 7 times, and 2 times 7 gives you 14. So the right-hand side is 15 over 49. Any questions so far? Okay. Now, because we have the same binomial on the left side, then we can write that as one exponent, as one binomial with an exponent of 2. So we have x minus 1 over 7 quantity squared equal to 15 over 49. Usually when you get to this point and completing the square, now you can switch gears and use the square root property. So we'll take the square root of both sides. On the left side, the root and the exponent cancel, leaving us with just x minus 1/7. On the right-hand side, don't forget your plus minus sign. Like we did with an earlier problem, we can rewrite this entire fraction with the numerator and denominator as radicals separately. So this is the same thing as plus or minus the square root of 15 all over square root of 49. And that gives us plus or minus square root of 15 all over 7. The last step, we need to get x by itself. So that means adding 1/7 to both sides. So our final answer, because we have the same denominator now on the right-hand side, we can write our answer as one whole fraction. So negative 1, no, positive 1, I'm so sorry, plus or minus the square root of 15 all over 7. Again, I don't mind you using other methods. If you wanted to use the quadratic formula, that's fine. Let's look at the next question. Use use the discriminant to determine the number and type of solutions for the given equation. The discriminant is the part of your quadratic formula that's under the radical sign, namely the b squared minus 4ac part. And in order to either find the discriminant or use the entire quadratic formula, your quadratic equation must be in the form ax squared plus or minus bx plus or minus c equal to 0. So our quadratic equation is in that form. Let me go over the possible scenarios. If your discriminant is greater than 0, then expect 2 rational solutions. If your discriminant is actually 0, then expect 1 repeated rational solution. And finally, if your discriminant is negative, then expect 2 imaginary solutions. So when we plug in, let's identify A, B, and C. So A is understood to be 1. B is understood to be, well, B is 2 and C is positive 8. So when we plug everything in, we got 2 squared minus 4 times 1 times 8. And that gives us 4 minus 32, or negative 28. Now, because negative 28 is less than 0, then that means we will have, if we had to solve this quadratic equation, we would have 2 imaginary solutions. Are there any questions about the last batch of problems? I'm actually going to stop here. I probably won't have enough time to finish the study guide given there are the amount of questions left. So what I'm going to do is make another video later, pick up with number 19, finish up the study guide, and I will post the second video also in Canvas for everyone. All right, well, thank you for joining this session, and I hope everyone, hope you have a good day, good rest of the day.